In this video, we're going to be looking at the quotient rule. In 1, it says the expression x to the 7th over x to the 4th can be written as x times x times x times x times x times x times x divided by x times x times x times x, or x times x times x divided by 1, which equals x to the 3rd. And then it wants to know what is the relationship between the exponents of x to the 7th over x to the 4th and x to the 3rd. And our relationship is 7 minus 4 is equal to 3. So if we have x to the 7th over x to the 4th, we could say that this is equal to x to the 7 minus 4, and that's equal to x cubed. In 2, it says simplify each expression. Your final answer should not contain negative exponents. If the expression has a negative exponent, begin by switching the position in the fraction and change the sign of the exponent. In A, we have x to the 11th divided by x cubed, and we could write that as x raised to the 11 minus 3, which is equal to x to the 8th. In B, we have x cubed divided by x to the 11th, and this would be equal to x to the 3 minus 11, or x to the negative 8th. And we want to rewrite this without a negative exponent, so we have x to the negative 8th in the numerator, and it becomes x to the positive 8 in the denominator. In C, we have x to the 11th divided by x to the negative 3rd, and the first thing we're going to want to do is write our x to the negative 3 as positive, so we're going to have x to the 11th times x to the 3rd, and x to the 11th times x to the 3rd is equal to x to the 14th. In D, we have x to the negative 11th divided by x to the 3rd, so we're going to rewrite this as 1 over x to the 3rd times x to the 11th. We want to make that negative 11 exponent positive, and this is equal to 1 over x to the 3rd times x to the 11th is x to the 14th. In E, we have negative 1 divided by x to the negative 3rd, and we can write this as negative 1 times x to the positive 3, and this is equal to negative x to the 3rd. In F, we have x to the 0 divided by x to the negative 8th, and we could write this as x to the 0 times x to the 8th. And remember, x to the 0 is equal to 1. So we could say that this is 1 times x to the 8th, and that's equal to x to the 8th. In 3, they want us to simplify each expression. Your final answer should not contain negative exponents. In A, we have 10x cubed x to the negative 6 divided by 2x to the negative 2 x to the 5th. The first thing they want us to do is apply the product rule to the numerator and denominator. So this is going to be equal to 10. And we have x cubed times x to the negative 6 gives us x to the negative 3. And in the denominator, we have 2, and we have x to the negative 2 times x to the 5th, and that's x to the 3rd. And now they want us to write without negative exponents, so we're going to have 10 in the numerator, and we're going to have 2x cubed from the denominator originally, and then the x to the negative 3 in the numerator becomes x cubed in the denominator. And now they want us to apply the product rule, so we're going to have 10 divided by 2, and we have x cubed times x cubed is x to the 6th. And now we want to simplify, and 10 divided by 2 is equal to 5, so we're going to have 5 over x to the 6th. In B, we have 2x to the negative 2 times x to the 4th times y to the negative 5th times y to the 6th, all divided by 10x times y to the negative third times x to the seventh times y to the negative fourth. And it wants us to apply the product rule to the numerator and the denominator. So we're going to have 2, and now we have x to the negative 2 times x to the fourth can be written as x squared, and y to the negative fifth times y to the sixth is equal to y, divided by 10. We have x times x to the seventh is x to the eighth, and y to the negative third times y to the negative fourth is equal to y to the negative seventh. And now it wants us to write it without negative exponents, so we're going to have 2x squared y divided by 10x to the eighth, and y to the negative seventh is going to move to the numerator as y to the seventh. And now they want us to apply the quotient rule. So we have 2, and we have x squared divided by x to the eighth is x to the negative 6, because 2 minus 8 is negative 6. And now we have y times y to the seventh, which we could write as y to the eighth, divided by 10. And now it wants us to write it without negative exponents. And we're also going to simplify 2 over 10. 2 over 10 simplifies to 1 over 5. So we're going to end up with y to the eighth in the numerator and 5x to the sixth in the denominator. In C, we have 5 squared times a to the fourth, c to the sixth, b to the negative 3, divided by 10 squared times b to the fifth, a to the negative eighth, and c squared. And the first thing they want us to do is write it without negative exponents. So we're going to say that this is equal to 5 squared a to the fourth, and we have a to the negative eighth in the denominator, so it becomes a to the eighth in the numerator, times c to the fifth, divided by 10 squared b to the fifth, and we have b to the negative 3 in the numerator, so it's going to become b cubed in the denominator, and then we have c squared in the denominator. And now they want us to apply the product rule to the numerator and the denominator, so we're going to have 5 squared, which can be written as 25. Now we have a to the fourth times a to the eighth, and that's equal to a to the 12th times c to the fifth, divided by 10 squared can be written as 100. And then we have b to the fifth times b cubed, and that's equal to b to the eighth times c squared. And now we want to apply the quotient rule. And the only variable we need to apply the quotient rule to is our c variable. So we have 25 a to the 12th, and now we have c to the fifth divided by c squared is going to be c cubed, divided by 100 b to the eighth. And now we want to simplify. And we can say that this is equal to 25 over 100 can be simplified down to 1 over 4. So we're going to be left with a to the 12th c cubed divided by 4b to the 8th. And that's our video on the quotient rule.